This is Quideo number 2, and the basic question asks whether the weight of 12 women correlates to the amount of calories that they burn. And for part A, it asks us to make a scatter plot, which I have done here. And on the x-axis you can see the weight of women represented in kilograms, ranging from 30 to 60 kilograms. And on the y-axis you can see the calories burnt in a 24-hour period, ranging from 900 to 1600 calories. And in this particular case, the weight of women is the explanatory value and the calories burned in 24 hours is the response variable. And then for part B, it asks us to describe the direction, strength, and form of the relationship. And I said that the graph represents a strong positive linear formation, as they are going in the same direction. They are progressing upwards as they go along the x-axis, and it takes a linear shape. In the advanced question, we are given a scenario of how many meters different age groups can walk in a 6-minute period. And for part A, it asks you to construct a least squares regression line, which I have done here. And it is y hat equals 492.7977 plus 14.7633x. And this slope shows how many more meters you can walk in a 6-minute period as you age. And I calculated this least square regression line by inputting this function on my calculator, and I found the variable a and b. In part B asks you to determine the residuals, as well as construct residual plot and determine if there are any unusual features. And I found the residuals here, and they are 4 equals negative 7.551, 7 equals negative 12.14, 10 equals 26.869, 13.5 equals 8.9974, and 17 equals negative 16.17. And I have constructed a residual plot here. And as you can see, on the x-axis are the ages from 0 to 20, and on the y-axis it ranges from negative 30 to positive 30. And there are 5 dots on this graph, and it shows how many, or rather, how strongly this graph is linear. And I found these residual plots by using this function on my calculator. And looking at this graph, you can see that this is indeed linear, and this shows that by having no unusual features such as a potential outlier or a curved graph, that this is indeed linear. For the AP question, we are given a graph of how many seats on a plane is correlated to the operating cost of a plane. And for part A, it asks us to make a least squares regression line, and I have done that here, which it is y hat equals 1136 plus 14.673x. And I found that by using the coefficient of constant as the variable a, and I used the coefficient of the seats as variable b. And for part B, it asks you to find the coefficient correlation, which I found here to be r equals 0.7550. And I found that by taking the square root of r squared, and that turned out to be 0.7550. And this means that the data has a strong positive correlation, which you can see in this graph that is provided. And for part C, it asks you if the least square regression line would still apply in the section on the x-axis from 250 to 350 seats, which is in this cluster right here. And I said that it does not, as the least square regression line would only touch one point and would be far from touching the other 6 in that section.